want to go straight to the quiz.
I mean, I think we should talk over it a little, the stuff. So, but yeah, like majority, let's do quiz.
Yeah, I just yeah.
Yeah, because I think we do. Yeah. Well, let's start with a prayer real quick,
Okay.
and
That's
then we
me this time, right?
can. Yeah. Thanks.
Dear Heavenly Father, we're grateful for the chance that we have to meet together to study and to get this done. We're grateful for your help as we're moving closer to the end of the semester, and we glad to be able to move forward. And I say things in the name of Jesus Christ, Amen.
Amen.
All right. Oh wow.
Okay. Let's hit the bricks. Okay. So preparation, did you have any problems at all? Or did you got like all the right answers?
Yeah. I
Okay.
mean, I
Yeah.
most of them. I mean, it
Yeah.
seems a lot like the same stuff we did earlier this week.
Yeah, it does.
I mean, we had the, sum and difference identities, but we'd talked about that a bit before, and that's on our sheet.
Yeah, it's just expanding a little bit on what we did before.
Yeah.
And you get the identities and everything.
I
Like for
obviously
that
haven't.
number 2 in team discussion.
Yeah, I
Just
haven't
to
completely memorized them, but
oh yeah, no, I haven't either. But I think they're pretty straightforward as well. And then extension problems. It's just this kind of itemizes how to do one problem.
okay.
And
Okay, if it's okay, hold on, sorry, because if it's the it would be plus. Okay, so the first one, the simplify A, we
yeah.
could just simplify that to the sign of A plus B.
Yeah. And then
Or no, sorry, the cosine of A plus B. No,
wait.
cosine of A minus B. No? Now I'm confusing myself.
Oh wait, yeah.
Oh, because it's cosine times cosine.
Yeah. Like um
Oh, okay. That would be the cosine of A minus B. So in this case, it would be the cosine of 47 minus 2.
okay. Yeah, and then
Sorry, I was like, I know the section. I know where it is.
yeah, no worries. I've been like go 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 all day actually for like 2 weeks, and so I feel like I just need to like
Nap.
quickly just like okay, words, all right, I'm good. And, like I know I need to actually go into it and like understand it.
Yeah, I'm at that point. I'm like, can we just stop learning and just finish?
Oh, I know. Oh, I want that, but then like looking at iLearn and seeing that we only have like 2 weeks left, it gets me so stressed.
Mm-hmm. Well, I love if you look at class project progress, you can see what your options for grades are. Like the highest you can get is this, the lowest you can get is this. And this class, it's still you could get
Where's
an A
that?
or an F. If you go into my grades and then go to class progress,
Okay. I'll look into that
it'll show
later.
you. Yeah, it'll
So
show you.
go ahead. Sorry.
No, it's okay. It'll show you your current grade, the maximum final you can get, and the minimum final you could get. So, like, I could get an A in this class as my maximum, or I could get an F. It's
Yikes.
literally still that up in the air, and I'm like,
Oh gosh.
yeah, that makes me fear for the final. But I don't think he's graded my exam yet, my written part.
Oh yeah. Oh, I
But the
don't want to
fact
know
that I
that
got
one.
the fact that I got a D on the multiple choice and I still have the option to get an A is kind of impressive, but still makes me fear for the future. Anyway, sorry, I ramble.
Yeah. Says my maximum final grade is B minus. Yeah, that's okay. It's good. It's
Oh,
good.
but you haven't gotten the homework for the first 4 weeks in yet, have you?
Oh yeah, no, I haven't. Well,
So,
some
I
of them.
mean,
I've done some of them. So yeah,
yeah,
it'll go up when I get like partial
yeah.
credit for that. Thanks for showing me that. That's really helpful. Takes off a lot of stress, actually. Hmm. Okay. Because at this point, I'm just like blowing it up in my mind, like I'm gonna fail everything, and I don't know what I'm doing. It's gonna be the end of the world. So
Nice.
anyway, so position. Okay. We so which question do we want to like I'm sorry, my brain isn't working. I start speaking and then I don't remember what I'm saying.
It's okay.
So what number like of the problem do we want to do? Like from 10, 11, 6?
Oh,
Because I know we have to. I mean, I guess we could skip them. Does he watch these? Like, does he sit an
I
hour
don't.
like for each for each like group and just
I
watch this?
cannot imagine that he does.
I'd go insane if I did that. But then still on the
Yeah.
off chance that he might just like watch this one randomly, I don't want to be like, oh, let's just skip everything and just pretend we got an A. I don't know. Because honestly, I don't
Well,
want to do 2
technically,
verifications and 3.
yeah, technically, our participation points are if we were here the entire time. It's not even if we do these.
Really? Are you
It's
kidding
yeah,
me?
yeah,
Oh
no. The
my
participation
gosh.
template, it goes didn't show up is 0, left early or came late is 5 points, and stayed the whole meeting
Really?
is 10. Yeah.
Well, okay. I had no idea. I don't think I looked at that, but I thought it was like, did you do number 10? Did you do number 11? So, man, I'm so sorry. For each meeting, I've been like, well, we should do this one and this one. I'm so sorry.
No, it's fine. No, it's good practice
Uh,
and it helps us learn it better, but
yeah,
technically
it's
no, it's
annoying.
just yeah, no, it's
Okay,
literally
well,
did you
then
show up? Yes.
I mean, it's okay. You know what? The same stuff on here is the same stuff on the group quiz. So we'll get practice anyway.
Yeah.
Right? I mean, we can just
Yeah.
check our work on the group quiz and it'll be fine. Okay.
Yeah. Hey, we're allowed to use all our resources.
Exactly. Okay. So,
Okay. Ooh. So your hubby in the background?
Yeah.
Nice.
Mhm. Mm.
Hmm.
Oh my gosh.
That's not what I need.
Okay. So,
Yeah. Okay, so to add fractions, we have to make sure they have a common denominator.
yeah. So, what I did for that, I actually got it started on that one.
Yeah.
You like do like the sine x times like the other one. So I'm really bad at explaining things, so I might just show you.
Hold on, let me get back into the thing.
Okay. So it's pretty
Okay.
much like you multiply the denominators so that they have a common one.
Mhm.
Right, and then I'm pretty sure I was right. Like for this, like it would become squared because you have to multiply the top as well. I think.
Do
And
we?
then
Oh, yeah, we would have to.
right. So it does become squared. I wasn't quite certain if I was right on that. And then this is where I become a little unsure of my work because I just figured like since both of the values in the numerator are
Uh huh.
squared and they're the same ones as in the denominator, can't we just like kind of cancel it and then we just have
I'm pretty sure.
the values of the
Yeah.
numerator? I feel like that's right. And then I wasn't quite sure like like if sine x plus 1 minus cosine x is really the most simplified that problem gets.
Yeah. Hold on one second.
Okay.
Because it would be sine squared plus 1 minus cosine x times sine x squared over sine x times. Sorry, I'm trying to catch up.
Oh yeah, no worries. I'm spacing out, looking at what my husband's doing. Um,
Nice. Okay. I
okay, let me go.
think. Sine squared of x plus sine of x? Okay, I think it would be. Let me check something really quickly.
Okay.
If you've got like sine squared of x plus sine of x, wouldn't it be sine cubed of x? Because hold on, because we
Okay.
end up getting the sine of 1 minus cosine of x is our basically our denominator. And wouldn't that cancel out basically everything on the left or on the right, except for sine x? Because well, sine x
Um,
squared divided by sine x would be sine x.
let's see. Let me look at it again. Um, wait. So the could you say it again?
Yes, however, I think I just realized I'm wrong.
Oh, okay. Um, so something I was also thinking about when I was going through and doing it. Um,
Uh-huh.
there's like those Pythagorean identities, and
Mm-hmm.
it says sine squared x plus cosine squared x equals 1.
Mm-hmm.
Um, so at the part of the problem where the numerator values are still squared, do you think there's
Yeah.
a way to arrange it to fit that Pythagorean identity? Or like for the 1, or would it not work out?
Perhaps. Give me one quick second.
Yeah, sure.
Sorry, I realized I had times by sine, but I hadn't times by the cosine.
Okay. You're good.
Okay. UK. Okay, so I got it to the point where it's sine squared x plus cosine squared x plus 1 over 1 minus cosine x sine x.
Whoa. Okay, is that from doing the Pythagorean identity, trying to find that?
No, that
Or
was
just the problem.
I went ahead and did the left side. I timesed it by sine of x over sine of x, so basically 1. And then the right side I times by 1 minus cosine of x over whatever, so we had the common denominator. So the left would have been sine squared of x over 1 minus.
Yeah.
And then the right would have been 1 minus cosine x squared. And so then I foiled that.
Yeah, I didn't foil it.
Okay.
Oh my gosh, I know what I did wrong. Why I got stuck. Okay.
Oh.
So I accidentally just put I didn't keep the two sides of the equation separate. And so when I canceled out a sine and the 1 minus cosine x, because of the squared, I should have left the other part of the I don't know, the sine or cosine for either side, but I don't know if that makes any sense. But it clicked in my head, and I'm probably still doing it wrong, but at least I caught something. So are you, do we need to foil them, or can you for the sine?
For the sine squared, I think we can leave it how it is. But for the 1 minus cosine x, we're timesing the entire equation, not just the single piece.
Yeah, and I think what I was trying to do I think that would bring us right back to the beginning of the problem. So I don't think that was right.
Okay, I think we can reduce it down to negative cosine squared of x plus sine of x. If I'm
Okay.
reducing correctly. Because, hold on, I'm going to hold this up to my camera.
Okay.
So that's where I had gotten to before.
Let me look. Okay. Excuse
And
me.
then I set it up a little neater.
Okay.
And so then I think we can reduce, obviously, the 1 over 1. And then
Okay.
pull it out like that. So I think we can. Hold on.
Yeah. Did
It
you like?
wouldn't be cosine of x. Sorry, it would be
I don't know.
negative cosine plus sine of x. So there we go.
Okay. Yeah. Are those ones? Yeah, I think that's right.
Okay.
And let's see, I got started a little bit on that next problem. The tangent theta. Okay.
A secant squared of a minus 1.
Yeah. So when you're ready, I think I have something to show you.
Sure.
So on here, when I started doing it, I like tried to plug in like an identity.
Yeah.
And this one I think still has to be squared. Do you know if man, am I dumb? Never mind. I just figured out I could just write it again instead of doing the squared thing. So then we'll have sine theta over cosine theta times 1 over sine theta times 1 over sine theta minus 1. Okay, so this is where I'm going now with it. And I think we can like cross cancel those two signs and then go from there.
Okay.
Does that seem right to you?
Can you hold still for one more second? Sorry, your camera's a little fuzzy.
Oh.
That looks right.
Okay. Sounds good. I'm gonna wipe off the camera a little bit just to make sure that's all clean. Okay.
So you did sine of A over cosine of A?
Yes. And then times 1 over sine theta or A times 1 over sine of A minus 1. So I just wrote out the square.
Yeah.
So then that gives us cosine A, right? And then times 1, which is just whatever, and then 1 over sine A minus 1, I think.
I'm pretty sure that we would have to times the sine sine of A over cosine of A times the minus 1 as well. So I think once we cancel it out and it's the 1 over the cosine of A.
Wait.
Because, like, since it's in the parentheses like that.
Yeah.
Like, if we were to read the 1 as a fraction, it'd be 1 over 1. So I think.
Oh, yeah, I think you're right.
So it'd be 1 of cosine A minus sine of A over cosine A. So 1 minus sine of A over. Hello.
It's for hot chocolate.
How'd you get these for?
$6, but it's one. I was just testing that one if it works. So put that one on top of the other one. Whatever.
Oh, it comes down with more water. That's cool. Check this out.
There's water in it.
We're having hot chocolate at our reception, but you're coming, right? Because your family's coming. That's right. So
Sorry.
It's okay. It's cute.
sorry.
Yeah, so we got married before the semester, and then we are just having our
Yeah.
reception December or so.
Nice.
Yeah. So
I think that maybe the farthest we can take it.
so with that -1 again, theta. So you're saying that the whole parentheses in the initial problem should be included in the square?
I think so.
Okay.
Or wait, no, hold on. No. Okay, here, hold on.
Okay.
So I wrote it out. And then I went ahead and
Okay.
times it. So the sine of A over cosine of A times sine of A cancel. Oh, hold on. I'm an idiot. I am an idiot. Sine of A. Sine of A. So that would cancel. That would cancel. So. Okay, I think it's -1 over the cosine of A.
The answer?
I think so.
Okay.
No, wait. No, it couldn't be.
Let me-
Then we'd have.
So 1 over sine theta minus 1 squared. So it'd be that. Okay. I need to step back a little bit.
Okay, hold on. I do too, because I just realized that the thing I had done, I can't just add sine of A onto it, because that would make it different denominators.
Oh.
So 1 over cosine
Times. This is
sine of A minus sine.
sine theta. Bless you.
It is still not correct.
Okay, so
Sine.
this go that would work. That won't work. So if we do cosine theta times 1, so that would be 0. Oh, wait, no. Let's just do that. So.
No, I think I may have been right the first time. I just confused myself by adding an extra step.
Okay, so if we times that, okay, cosine theta times 0 times 1 over sine theta minus.
Oh, wait a second. Oh, no.
Do you get a 0, like multiply by 0 at some point?
Not that I know of.
Really? Because what I'm probably way off on this, but um, I what is it? So I redid like that square, so then I have that -1 or -1, and so then I cross canceled with that. Maybe I shouldn't do it with the parentheses. I'm not sure, but then I get like a cosine times the 1 minus 1 that's left over. So then I get a 0, and then the rest of the problem.
Where are you getting the 0 from?
Because when I cross cancel those signs, and so then that leaves
Yeah.
me with the 1 right here, and so inside that
Yeah,
parentheses I have that -1. So 1
right,
minus 1, that's the 0.
that would become a 1. It wouldn't become a 0. Because it's the same thing as sine of
Really?
x over sine of x equals 1. Yeah.
Wait, sine of x. No, I'm not
Even
doing sine of x.
when you're crossing it out, or sine of a, when you're
Uh-huh.
crossing it out, um, like if you went ahead and multiplied the whole thing out and then like took them out, it would be the same thing as multiplying by 1. It wouldn't be multiplying by 0. It wouldn't be making anything a 0.
Okay. All right. Yes. Yes. Okay. I think your answer is probably the right.
Yeah, I'm just not sure if I'm supposed to break it down or leave it how it is.
What
'Cause
is it
could either
again?
be 1 minus. Well, it could either be 1 minus the sine of a over cosine of a, or it could be 1 over cosine minus tangent of a.
1 over cosine minus tangent A?
Yeah, I'm just not sure which one would be the correct simplified version.
Okay. And the first one, did you say that it was 1 minus sine over A over sine of, wait, no, sine A over sine A?
Cosine of a.
Oh, cosine of A. I was like, oh, that would just be 1. So cosine of A.
My gut is saying that's the proper one because it's more condensed than the other.
Yeah, I feel like that would be it. And
Kind of nice that there's only
yeah,
2
I don't know.
problems.
I'd feel more comfortable doing the 1 minus sine A over cosine.
Okay.
Because then we're not bringing a different tangent into the
Yeah.
mix, and I'm not sure with that.
Okay. Oh, sorry.
Good job, though.
Thanks.
Verify. Do you think verify or simplifying is easier?
I kind of think that verifying is because if you can find anything that proves it wrong.
Yeah. And I feel like you already have both sides of the equation. You don't have to.
Yes.
You're just trying to find a yes or no instead of a, like, any possible answer.
Yes. Nope, those are equal.
Excuse me. Oh my gosh. Okay, let's see.
Cosine squared of x times 1 over cosine of x. The over cosine. Then cotangents. I got the right side on A figured out. I'm still trying to figure out the left side though.
Okay. Excuse me. I'm trying to open up the textbook. 16, 2.
I wonder if it would be easier to do it that way. Thinking it might be. When you're dividing by a fraction, you flip the fraction and multiply, right?
Yeah, you flip the right side and multiply.
Okay, I think I may have gotten it then.
Oh, nice. And what is it?
Okay, give me just 1 second.
I didn't get anything useful.
Okay. So click back into here so I can actually see what I'm doing. Okay. So wrote out the problem. I substituted. Okay, I can't do this. Okay, I substitute on the right side. I substituted secant for 1 over the cosine of x. So then I went ahead and did the cosine squared of x times 1 over cosine of x, which would have given cosine squared of x over cosine. So that would just reduce down to cosine. And then on the right, or left, sorry, that was the right. On the left, I went ahead and changed cotangent for 1 over the tangent of x. And then replaced tangent with the sine over cosine. So flipped it, so it was 1 over 1 times cosine over sine.
Wait, you replaced a tangent?
Yes. Yeah, I went cotangent to tangent to the sine over cosine.
Okay.
So then when you times that by sine, you get cosine x, sine x over the sine of x. Reduce that down, you get cosine of x minus cosine of x equals 0.
Okay. That seems right to me. In my very professional opinion, I think that's right. A and then B. That's 1 minus sine squared x.
Secant of negative.
Do we have to do multiple verifications?
No.
Okay.
If we're
trying to find if it's false, we would. But if
it's shoot, what's it called? Like, I'm not entirely positive.
it's fine.
This is where we're proving that both sides equal each other. The other one is like if you have a formula, if you can prove anything that makes the formula false.
Okay.
So I think.
Okay. Yeah. Thank you. Sine minus x. Cosecant x. Okay. So, ouch. If we do.
Excuse me.
You're good. What am I looking at? Okay. Sine squared.
To be honest, I have no idea where to go with this one.
1. I might be onto something, or it might just be nothing.
Okay.
Cosecant. Cosecant, so that's 1 over sine. Well, it's not really helping. X. Do you think it would be bad if the first thing we did was to cancel out those ones on the left side? And that, I guess that would just leave us with negative sines and cosecants, huh?
Yes, I think so.
Because I was thinking it'd be easier if we didn't have to deal with those, but we do.
Yeah.
One. Dang it. What do we?
Oh, actually,
So, can I show this part to you? It's just the left side. And I don't know if it's like even right, but instead of writing, so I'm sorry, they're doing something weird. Okay, so instead of writing the division like stacked up with each other, and I like replaced the identities, so then I have that, which would normally, hey, okay, without the ones, it would be easy because then we could like do the division and just do the reciprocal and multiply everything, but I'm not sure what to do about those ones. So
well, let's try canceling them out and then.
Okay. So I'll have a negative. I'll just put the negative outside the parentheses. Okay, so I'll have.
But okay, if we canceled the ones out, wouldn't that give us sine cubed of x? Which is technically taking us farther away from where we need to be.
Cubed.
Because if we were doing the reciprocal, we would flip the fraction on the bottom.
And
so I don't think that's what we need to do.
Okay. Times I'm just gonna put it in front of all of them. So negative and negative. That would be a -1, so we could do that. That, and then we could get what about the sine? What if we just left
is it possible that it's just not possible?
I have no idea.
Okay, hold on 1 second. I'm gonna check and see if in the preparation. I'm gonna check something.
If we just left that, it would just be cosecant. Oh, I did a typo. That should be negative. Okay.
Oh.
You get down. Sorry, my cat jumped on the. He jumped up on the counter. And I was gonna go tell him off. Okay, Okay. If we just left that, just did cosecant. Okay, I might have an idea if we do negative cosecant. one. And then that one give us... Oh, no, that just give us... Times negative over cosecant x. Okay. So I think it would just be negative 3 over No, we can't do that. Oh, we can't. No. Let's say -1. So we get, well, that's just 1 over cosecant x squared times -1 over cosecant negative x. So far I'm at, just for that left side, 1 over cosecant x squared, so like the cosecant squared x, times negative 1 over cosecant negative x.
Okay.
And yeah, because on the left side, so at the very beginning for the denominator, I just left the cosecant like the same, so I didn't replace it with anything. So, you know, everything on that left side would be in terms of cosecant.
Okay.
So then just working it out, I just got what I said. But so then I don't... I guess the problem I'm running into is how to deal with the negative x in that other cosecant.
Yeah.
Would it just... So if you multiply this out,
Yeah.
trying to like think of the words to explain what I'm trying to ask. So I have so if that x wasn't negative, we could write it as -1 over cosecant cubed x. But because it is negative, can we still do that and just write it, the denominator, as a negative x cubed? Or, man, I'm forgetting my algebra. Man.
Okay, hold on. I may, keyword here, may be onto something.
Okay.
Yeah, no, I'm not sure where I was going with that.
Let's see. So let's say just in algebra, if we have x squared times negative x,
Okay.
would that just be negative
X cubed.
negative x cubed?
If it's x squared and then you times it by x again, yeah, it
Yeah.
would be go from
Well-
squared to cubed.
Yeah. So even if it's a negative, it would
Mhm.
just make everything negative. Okay. All right. So then let's say we have so negative 1 over cosecant cubed x. That's what I get. Is this one? So for the left side, just a negative 1 over cosecant cubed x.
Huh.
And I feel like that's all I can do for that side.
Yeah.
Anyways.
I'll be honest, I'm not entirely sure this is possible.
Yeah, I mean, if it were up to me, like, and my understanding, nothing in trigonometry would probably be, I mean, a couple of things would. The things I get. Everything else is impossible.
Okay. Hold on. I'm just gonna really quickly. 1 minus sine squared. Oh, let's do pi. Pi's easy. 1 minus the cosecant of negative pi.
Sine.
1 plus the sine of negative pi over the cosecant of pi. We're allowed to use calculators, so I'm just going to plug in pi because it's simple, and I'm just going to see if they actually equal each other. If they don't actually
Okay.
equal each other, I'm just going to say it's not freaking possible.
I really hope it's not.
Okay, 1 minus the sine. Whoa. Menu. Are you kidding me?
So it actually equals something.
No, it's the calculator app that I was using and loved so much.
Uh-huh.
It apparently was a trial. And now it's saying if I
Oh.
want to have the calculator that shows me stuff, I have to upgrade to Pro, which costs $3.
I hate when it does that.
That's just a jerk move.
Yeah.
Well, that calculator's going bye-bye. You uninstall. I don't like you anymore. Okay. Scientific calculator on. Okay, 1
Okay. I don't.
minus.
Let's see. I think I'm really, really close to this. So, yes, I'll show you if you're not busy. So, I started working on the other side, and I get similar to this side. If I worked this all out, at least for the denominator, it would be negative cosecant squared x. And this is cubed x.
Yeah.
So I feel like it should be close to something, or like, I mean, is there something we need to do to make that one of them?
That is a very, very
I don't
good
know.
question. Sorry, I'm trying to find a scientific calculator that has cosecant on it.
Yeah. Cosecant. So if we have 1 plus that.
Yes.
Plus,
Okay,
that would
this
be
one has
1
everything I need.
over negative cosecant squared x plus 1. What do you do with the plus 1? Oh, I'm so close.
Where is pi? Oh, there's pi.
Wait.
Are you kidding me?
Does it not equal each other?
Well, I think. I don't think it's possible in general. Either
Yeah.
side of the equation, because I
I
plugged
don't
in
think
pi.
so.
Well, the cosecant of pi is 1 over 0.
You're kidding me.
No.
Okay, and I feel like it's the same deal because number 1, on one side we have cosecant cubed, and the other side we have cosecant squared. And then I just realized I had made a mistake with my negatives, and we would have the left side be positive and the left side negative. And I feel like that's one way we could tell that it wouldn't equal each other, and if 1 over 0 or whatever, 0 over 1.
Okay. So you cool with saying that it's impossible?
Yes, I feel like it is.
Okay, then I am going to go ahead and
Okay.
submit this.
Great.
At
Thank
least
you
I know-
very much.
Yeah. At least I know one app that never lets me down. Cam scanner.
Ah,
All
there
right,
you
I'm
go.
going to stop broadcasting.
Okay.